So first of all, you're very, very welcome to this session, Dataflow, Power BI data flows and how to build your own orchestration of them. It's something that I was challenged with at a couple of customer solutions, and I put something together. All of the code is shared with you on GitHub at the end. You'll see that link in the last slide. Just really quickly about myself. I live in Ireland, been living there for 25 years, originally from Australia. Kept my accent as much as I could. I own a small Power BI and data platform consulting company called Datalineo. Been in business for kind of 6 years now. I cut my cloth with SQL Server back in the late 90s, building data warehouses for banks and stuff like that. So I've been around the data space for a good while. I'm Microsoft MVP and also run user group, the Dublin Power BI / Dublin Fabric user group, and there's an annual event in Dublin which is in June this year called Datalineo, and really looking forward to that. We did it last year, and it's something myself and a few other Irish folks have been running for probably 10 years, running the annual event. All my contact details are there, and then also on the last slide as well. So what are we going to do today? Orchestrating data flows, okay? I'm going to start with a demo, and I'm going to show you a number of data flows that I've put together, and I'm going to run them in the order that I want, that there's a dependency between them, and we're going to see it in action, and then we're going to stop and go back and open up the bonnet and say, how did that work? And it'll be something, again, that you'll be able to take home with you and implement if you are challenged by this scenario. There's also a little bit of extra time talking about the enhanced compute engine, which is a factor in this because there are orchestration changes when that is applied. And if it's not something you've used before, it's quite a powerful thing, and I'll talk about it towards the end, and we'll see some numbers as to what impact it has. And time permitting, I've built the same orchestration using Fabric pipelines. I'm just going to run them. We're not going to really go into them too much. It's not really the core part of today. But I mean, if you don't do something in Fabric soon enough, then the method that I'm doing is probably going to start to become a little bit redundant as the Fabric way starts to really kick off. So first things first, I'm going to demo, okay? What you see on your screen is the bird's eye view of 6 data flows that I've built. There are 2 sort of data streams, and across the top is Power BI user activity data. So I've downloaded the JSON files, and I've got like 10 of them. I haven't got enormous data volumes in this one. I read those files, so there's a staging from the source where I read them, a second one where I take that data and I create dimensions from it. So I take the unique list of activity types and maybe the unique list of users and create dimensions with a surrogate key. So I have a nice numeric 1, 2, 3, 4, which is a nice way to build your data model. And then from that, there's another dependency further down the line where I take and build a fact table. And the fact table requires the numbers that were made in the previous data flow. So there's a dependency 3 hops. The bottom one is the same thing, but it's just different data. There's no dependency between the top row and the bottom row, which means that I can effectively run the first 2 together, and then the next 2 together, and then the next 2 together. Okay? So what I'm going to do, I'm going to open up a Power BI workspace. We're going to see those data flows in my Power BI workspace. So here they are, staging activity, and I've numbered them. So 1 and 1 are the first 2, 2 and 2, 3 and 3. So these are the 6 data flows that were in that diagram. I'm kicking this off from my phone because I'm using Power Automate. My Wi-Fi has been a little bit of a challenge today, but we're okay. So what we're going to see now is when that kicks off, the first 2 data flows start to run. And while we wait, first 2 are running. They take about 5 seconds each. Any Brazilians here? Okay, this is a very, very famous Brazilian keyboard player. Okay, we're on to the second 2. Off they go. We can leave that. And we now have a process that is running the first 2 together, There's no dependency between them two, the second two, and the last two. Simple, easy, but how do we do it? Last gone? No, they'll kick off in a second. Okay, and off they go. So let's take a step back and see how did we do that. At the beginning, I talked with you all about data flows and who's using them. I'm going to be as brief as I can on this because I don't think you'd be here if you're looking to see what data flows are. But all the same, just for coverage, let's talk a little bit about what they do. So 1, 2, 3, 4 data flows you can see in this diagram are pulling data from various places, which is a wonderful part of data flows. They're very quick and easy to set up and connect to whatever. And we see a subsequent data flow at the top, which is dependent on the first one. And in the middle, we see the icon, which is the Power BI semantic model. So the purpose of building those data flows was to bring data from multiple places and ultimately have data in the good structure that we need for a Power BI semantic model. Our facts, our dimensions, nice and clean, not a lot of garbage, no duplication, and all that kind of good stuff. And then from the semantic model, we have reports, okay? So this diagram here indicates somebody who's using data flows effectively as a mini data warehouse sort of thing, or an ETL tool. And those bullet points there cover what they are. I remember when they were introduced in around 2018, I saw them and I thought it fills an excellent gap in the Power BI world where you don't have an ETL tool. Some of my customers, you just get the Power BI platform, but you don't get access to Azure because it's just locked down, and if you're a third party coming in, tools are limited, and in some cases you need a way to clean the data, and hey, this stood in and made an excellent choice for that. The scheduling of data flows is basically per data flow on a time basis, so there's no run this one and this one, so there's no orchestration capability. Within each data flow, think of it as a bucket, and within that bucket there can be multiple tables. And within that data flow, tables can have dependencies within each other, and that's fine, that's handled within that one. But sometimes it's better to split your queries into separate data flows, and that is because sometimes downstream, you might have multiple places where you want to read the data upstream, so let's not repeat too many times. It's a performance and I suppose, an optimization concept. But doing that, you create a limitation in orchestration because the downstream stuff doesn't know the upstream stuff. You can't orchestrate it very easily, and hence this session and what we're going to cover. My helpers, is there any questions online or anything? Okay. Please do raise questions as we go along. Feel free, and I'll remind myself to repeat them so everyone can hear. Okay, so how did I do that thing that we saw running those 6 data flows in order? We have here on the left 3 purple boxes, and within each box there is a list of data flows. In my demo that I just did a minute ago, there was 2 data flows in each one, and there was 3 boxes. So let's call each one a block, and in each block we can have one-to-many data flows. When the block is run and finished, it will say, okay, all those 3 or 2 or whatever are finished. I will move to the next block. I'm initiating this process using Power Automate, and again, I'll show you that in a few moments. But the execution of the data flows is using Azure functions. Okay, the Azure functions themselves are calling the Power BI REST APIs. So we're right down to actually what's happening. There's 2 Power BI REST APIs that I'm relying on, and I've created 2 Azure functions for each one. One is to start the data flow, and the second one is to check its status. And it just comes back and says it's running or it's not running. But the way I've written my the way I've written my Azure function is I can pass a list of data flows to the Azure function, and it will come back and check all of the lists and say they're all finished or one of them is still running. Does that make sense? This is kind of list-based and group-based because we're running things in blocks and so forth. We have a question.
Yeah, why would you use the Azure function? I thought you can do everything with Power Automate.
You can, but it's a little bit more difficult with the orchestration and processing, calling those Power BI REST APIs within Power Automate. For me, it was personally probably a little bit as much of that as well, way easier for me to create the Azure functions, which do a little bit more error handling, marshalling, and so forth. If you tried to do what I'm doing here in Power Automate, your automate would become huge, because it's not saying run one data flow, it's passing a list of data flows to the Azure function, and the Azure function is doing more than one thing. It's running all of the list, checking that they all succeeded. If something went wrong, it would handle that and do an error. And even more so, if you're checking the status of multiple data flows, you pass 3 data flows and say, I need to see the status of all 3. Doing that in Power Automate was a challenge. So I went and said, I'm going to take that specific workload, I'm going to make a function, an Azure function out of it, and Power Automate will just marshal the execution of them. Okay? It's the number one question that gets asked in this case. If you try to do what I'm doing in Power Automate, it becomes quite cumbersome. Okay? So yeah, look, what's the diagram showing us? The Power Automate, which calls the Azure function, is grabbing the first block. And how is that first block itemized? It's a JSON list. So I have a list with lists within each one. So the list of 3 of blocks, and within each block, a list of data flows, arrays, let's say. Okay? So Power Automate is handling that part, grabbing the first block, going over, and you see it starts the for, and then it says, okay, every few seconds, I'm going to poll the for, and I will see 4 running. I'll poll again and see 4 running, and then probably 3 running, and so forth, down to, okay, all are finished, my status is complete. I will then pass back and say, I'm now going to do my next block, and rinse and repeat. Does that make sense? Okay. So let's do a little bit of a code review. So the 2 things that are being used in this process are Azure functions. So we're going to open up a Python script. Now, the Python script isn't the full Azure function as such, but it's the key elements done in a way that I can just run that script and show you how it works. But it'll show you how it authenticates, which Power BI endpoint it calls, and how it manages the list and so forth. And then we're going to open up the Power Automate itself and do an execution of what we just saw again, and see how did I itemize or parameterize the list of data flows that I want in the order, how does it handle the looping, and so forth. And we'll run it all again, and at that point we're kind of done with that. And then we've got a little bit of additional stuff to do about a little bit more advanced orchestration when things come to larger data sets in Power BI. Okay, so I'm going to pop open Visual Studio Code. Okay. Now, being a good citizen, all my authentication is hidden away. But effectively, we're using the Azure Identity module in Python. We have our JSON and our requests to call the API. This is just grabbing our tenant ID, client ID, and client secret. This part here is not usually in the Azure function itself. It's in the Power Automate, and it's passed to my Azure function. But in this case, again, I'm just ripping things out and hard coding so we can wander through a simple example and see it run. Okay. The JSON here, like I said, has an outer list, which is this array here. And within each one, there's multiple lists. I've minimized this. I'm not going to run 2, then 2, then 2. It's just the first 2. And that's why you only see 2 chunks of data there. What you'll also see is the name of the data flow here. But that's actually not important. That's just for the person running this to know which one is running. It's not referred to in the code, or it's not reliant on calling the API. It's really the workspace and the actual data flow GUIDs that are important in this case. Can you see that code okay? Do you want me to increase the font, or are we okay? All right. We get on to authentication. Again, using the Azure Identity module in Python, which is really, really good for any automation that you're doing in Power BI. I've written a blog on it. I started off using the module called MSAL, and then I moved to the Azure Identity, which is a simplified version of that for anybody doing Power BI automation. It's the kind of simplified one. It itself calls on MSAL, but it's much easier for basic token grabbing and authentication to Power BI. I'm using the client secret credential. There's multiple ways you can authenticate. You can authenticate in the browser and it will actually pop up and you can type your password in. So if you're running it in person, you can do that. And there's a couple of other different ways. But here, for Power BI purposes, this is probably the recommended one for anything that you're doing regarding automation. For that, you would need the Power BI, or in Azure, you would need an app registration created to get a client ID, a secret, and the relevant permissions applied to that app registration so that you can execute your stuff in Power BI. So a couple of quick lines. We have our token, we set our header and our body, and here is where we're going through effectively this list here, and we go, okay, now for every item in this list of data flows, and for every one within each of those, let's grab the name, the workspace, and the Dataflow GUIDs. And here is where we create our endpoint, and nice and easy, where we just pass in the workspace GUID and the Dataflow GUID, and we are calling the refreshers endpoint. And here we just run, okay? We've done our authentication, we've created the parameters and body that we need, and we say, go, okay? And in this loop here, it's going to do it twice because I've got 2 items in that first bucket. So it's going to run this 2 times. And I'm generating here a list of things that I have executed. And at the end, I can pass that back to Power Automate with a message to say, yes, they succeeded. What I've stripped away quite a bit from this script is error handling. In my actual Azure function, I'm checking the response status and the text, and if there is a failure in running that API, there will be a piece of JSON generated by the Azure function that goes back to the Power Automate flow, which can then say, oh, something went wrong, and the Power Automate can send an email, say, something broke, they didn't finish, you need to check on this, and then it's up to you to fix the problem. The return message, again, I'm going to run this, and it's just the output of the success or failure of these. Again, this is very hard-coded. It's fully expecting a success. There would be an error handling section here that said if it failed, go and pass back a failure, where Power Automate can grab the JSON response and, again, look for that status and continue or not. So let's go ahead and run this script. And go to Power BI, and what we'll see is something interesting. It's kind of a Wi-Fi issue by the looks. I'm just going to see if I can switch to my hotspot. Come on. I need my samba music on again. Walter Wanderlei is the name of that guy. I actually searched Spotify for elevator music, and his name was everywhere. So he's the person from Brazil. Okay, I've got a bit of a Wi-Fi issue, so if you just bear with me for 1 second. Maybe it did finish, it's just this page is not coming up. Ouch. Okay, I'm going to switch back, and you're just going to have to trust me that that worked. And if I can't get back onto Wi-Fi, is there a network in here? Yep. Okay. Is there a cable here? Okay. Okay, so you can see here the 1220, so that script did run. And my helpers are going to let me know if there's a Ethernet. No, there's not. So my apologies, folks. It does seem like it's a bit of a problem ongoing, so not much I can do, but let's try and push on. Okay. So let's open up the Power Automate. Who's using Power Automate? Okay. So I've been doing Power BI and SQL for ages, and I got my hands on Power Automate when it first came out. And immediately I'm like, this tool is just excellent. I find if you're a Power BI person, and even coming from a data warehousey background, there's a good enough learning curve because you get into Power Query, which is new, DAX, which was new back then. And so there's a steep curve until you become kind of comfortable at building solutions. I found Power Automate, or Flow as it was back then, is kind of like click, click, and it's very easy. And what made it so easy is that it comes with tons of templates just to show you how to build a few scenarios, and it's easy to edit them and get a feeling of how they work. So that's my sales pitch for Power Automate done. This is the actual flow. So I have one called Data Orchestration. If we go into edit mode here, this is the one that I ran from my phone. So it's triggered by a manual trigger, and on your phone you can have a button on. You can add a button to your front page and just be walking around as cool as ice and kick off your data flows like that. Impress everybody. People will be like, "Wow, I can't believe you kicked off data flows from your phone." Yes, sir. We have a question.
I think it's all good to find in this solution. Is there, sorry, maybe a silly question that on Power BI, do you not have a scheduled refresh of the data flows?
Yes. So something I covered at the beginning was data flows have a scheduled refresh, but no dependency between them. So I can't schedule this one and then say, when that one's finished, run this one. And that's the whole purpose of this session, is that gap is there, and this aims to fill that gap. Okay, so yeah, I manually trigger the flow. That kicks us off. This is the code that I use to authenticate to my Azure function. Again, I've lowered the bar on security of my Azure function for the purpose of this session. So it's just the code. The function is open to the internet. If I shared you the code, you could go and kick off all my data flows all day long. But generally, I would wrap a bit more security around Azure functions with either private endpoints or authenticating with Azure or Entra ID. Question?
So I was wondering if you considered scheduling the first step of the flow, and then have the dependencies look for when that one's done, rather than manually triggering that.
So how do you mean for the dependencies to know when it's finished?
Well, however they're doing it here.
They're doing it here because I'm managing them in my way. So I'm saying run to, and I'm saying in my code, check, check, check for finish. And when I know that they're finished, I'm managing the second two. There's no kind of standard built-in way to schedule one and then two, and have two run when one's finished, unless you lift back and do it your own kind of marshaled way. And I'm basically leveraging the REST APIs, two REST APIs to do that.
Yes, I'm just suggesting replacing that first step.
Mm-hmm.
instead of manually triggering your flow, it would be triggered by a scheduled refresh.
Possibly, but the scheduled refresh isn't going to marshal the subsequent ones, right?
It's just serving as a trigger for the subsequent ones.
I don't think I'm getting how you're making that work, though. So you can use Power Automate to trigger the first ones, or something else to trigger the first ones.
Yeah.
Yeah.
In Power Automate, and then subsequently let them trigger the other ones.
Let who trigger the other ones?
So in Power Automate, when one is finished, then that's the trigger for the next one. So you put that all in one.
Ah, okay. So you've raised a really good point that I probably neglected to articulate. When Power Automate triggers a data flow, it's an asynchronous trigger. It runs it and says goodbye. It doesn't run it and wait.
No, but you can, after it's finished, you can do select whether if it's been successful, then you do the next step. If it's not successful, do something else.
How do you know if it's successful or not?
It will, if the refresh fails.
But Power Automate doesn't have that information.
You monitor it the same way you're monitoring here.
Yeah, so I think I covered that question before. Doing it the way I'm doing it is marshalling multiple data flows to run in parallel, and then another bucket of multiple data flows in parallel. If you tried to do that in Power Automate, you could probably do it, but you would end up with a very spaghetti version of a flow. So I'm taking what you're thinking out and putting them in as your functions, and using Power Automate just for the lower level orchestration part. Okay? We can take that question offline, if that's okay. Yes?
So for 6 data flows, this looks easy. But
Yes.
for 100,
Yes.
it's more complicated. You have more steps, rules to order.
Mhm.
So 2 questions. How you can automatically get the catalog of all the data flows you have already in Power BI,
Mhm.
and I imagine that you store it in some place and then you organize them. But how you get this catalog? And the second question is, if your orchestration fail for some reason, I cannot continue with the next step. What is your mechanism to restart and know from which one I need to restart?
Okay, so there was 2 questions there. First one is, this is a nice demo for 6 data flows. And of course, that's what I'm going to do in a session like this, just to kind of talk about the concept. But what happens if there's hundreds of data flows that there are a lot of dependencies? And how do I get the list of data flows in my workspace or workspaces and build that out? So one, there are queries that you can, REST API queries that you can extract all data flows from your workspace or workspaces, but that just lists them out. It doesn't give you the dependency order. What you need to build yourself with metadata is the list of order yourself. And we do that with a JSON structure. So you can get all your list, here's your 100, but I know I need to do those 2, then those 3, then those 5, and I need to create metadata to tell my process which ones to run in which order. Okay? And just repeat the second question.
If the process fails?
If the process fails, yes. So the second question is, what happens if it dies halfway through? As it happens, I have a slightly more advanced version of this that I've about 90% completed, that there is a little piece of information called a retry count. Because if the response back from my my Azure function indicates that one of them failed, my Power Automate can put a process is to wait and repeat again and try 1, 2, 3 times. And if it fails 3 times, it will say, okay, that's it, I'm out. Because sometimes with data flows, there can be a transient error. That connectivity to SharePoint, for example, can sometimes, okay, it's not working, but you wait and try again, and it will repeat. So there is a process that you can take the response and wait and try again. Okay?
And will these data flows be incremental refresh, or it's because you're restarting from the point?
If they're incremental refresh, the refreshing of the data flow will handle the incremental refresh itself. Okay, so all we're doing is saying run or not run. It doesn't say run or refresh partitions, which is not something you can do. Okay, so this is going to answer your question a little bit as to how do I pass my process in. And here is a list which I'm going to copy into notepad. This is effectively how I use metadata, and I'm using JSON just because Power Automate is good at handling it, Azure Functions are good at handling it, and that's the way I'm storing my data. I've created one outer array, and within the first item of that array, there are 2 items, okay? And you'll see those, if you've got a photographic memory, you'll see those are the 2 Dataflow GUIDs that were in my Visual Studio script, and it just ran them. But in this case, we're going to say run those 2, then run those 2. And to your question before, you can see here I have a retry count. But I'm actually not covering that today because it's just not quite good enough to demo. It's a bit flaky, so I'm effectively just not going to talk about that part. My next 2 and my last 2. If I need to change this to add more or remove more, I've got options where I can just edit the flow and add it into here, or I could read that from a file that I'm managing properly by somebody and a team who are managing that orchestration, and Power Automate can say, that's my orchestration structure, I'll read that, instead of what I've done here is hard code into the flow, okay? So you can, again, I'm trimming this way down just to show the point, okay? But it's, you know, we can enterprise it up with a few other more industrial strength things. Okay, so I create just a status to default to in progress, which I'm going to be using a little bit later on. And here's where the work is done inside this scope item. So we take my text JSON that I have and compose it into a JSON structure. And the reason I do that, so this is a compose action. It takes the JSON and turns it into arrays and items so I can loop. Simple as that. The other piece was just a block of text. A compose is going to say, okay, now I can loop through item 1, 2, and 3. And for each one, we're going to get the current item. So it's the first block of 2 things. I'm going to execute each one. I'm going to do a delay, which I'm going to come back to in a second. And then once they're running, I'm going to continually poll and check the status. And this trigger here is calling my Azure function, okay? So this is the function that I created and I deployed to my tenant. I'm authenticating with the variable that I have in my API code, and I'm passing the data flows in that first block, okay? It sounds highly engineered, right? But when you trim it down, it's very little that it's doing. It's just marshalling, running data flows in an order, and checking their status. That's all really the crux of this demo is about. Okay, so I check the status. I go through, and my response to this status will look like this, which is in my, where have I got it? Here. My Azure function will pass back this, because it runs, it checks 2 data flows and checks both of their status. And if either one of them are in progress, the top part of my JSON will say in progress. So we've got status success, meaning my APIs ran. List status, meaning across all of the data flows, if any are in progress, then it's in progress, meaning, okay, you have to keep going because something's running, so I'm going to wait. But also the bit of detail about which data flows I checked and what each individual ones were, okay? I take a 2-second delay because I don't want to be polling every millisecond or however quick this can run. We just take 2 seconds. If the full duration of my data flows is long, I'm not going to poll every 2 seconds. I don't want to be hitting it too hard. I want to be nice to the Microsoft platform and not be smashing it with API calls every 2 seconds. But if it's long, I would probably increase that to every 10 seconds. And that would not add a lot of overhead if your duration is going to be an hour or whatever, if you've got huge data flows. Now going back here, this is the trigger that executed the data flows, and I did a delay here of 5 seconds. And the reason for that is when that triggers the data flows to run, it's not instant that they're running. There's a bit of time that the REST API triggers the refresh, and the data that's available to me will start showing that they're running. It was a bit of a problem that I had because every time I ran them, it would go straight through and check their status and say they're finished. But that's because they hadn't actually started yet. So I have to wait and say, okay, just wait a second, let them kick off, and now the transaction response will say, oh, now they're actually running. Okay, so if I go back and we run that, and we're not going to sit and watch, but here we'll see, again, the same thing. The first two kick off, and so on and so forth. Okay? And that's the refresh orchestration. It comes down to running them in groups that I want, and I orchestrate the execution order and keep checking them until the ones that I want to be finished are finished, and I move on to the next block. Okay? So they're off and running. Is there any other questions this time? Yes?
Does this work at all with like linked data flows? Doesn't that do some of the stuff
Yep.
already?
Yes. And that's my next point. Yep. Okay. Now, linked entities and the enhanced compute engine. Okay. Two small things that I want to cover which heavily affect the way you should think about orchestration. What I've done with those data flows is they are dependent on each other, and I have turned off the link between them by enabling the load. Okay, so what does that mean? Has anybody kind of comfortable enough used and tested the enhanced compute engine and linked entities and computed entities? Okay, so this is a really powerful thing that we've managed to get a good grasp on, and some of the impact times to your dependent data flows can be massive. So what I have here, two last things to kind of talk about. The enhanced compute engine, which is a direct thought process when you're saying, yeah, Ben said I can run those three and then those two and then those, but is there another thing I should consider if there are dependencies between my data flows? And yes, there absolutely is. And then the other thing is Fabric. And again, I'm just going to show you a pipeline, and we're going to run it. And we're not really going to open it up and go into too much detail because it wasn't really part of the core element of this session. But hey, Fabric, we've got to do something, right? So let's have a quick look at these data flows. So I have first two data flows here. This one here is reading, I think, like 15 JSON files with 1 day's worth of activity on each one. It's reading them, converting the JSON, combining them, and flattening them, and then, hey presto, that's it. It doesn't do anything other than that. So it's just creating a raw data set, no cleanup, no transformations, or anything. The sales one is doing the same thing, reading CSV data. But what I'm going to do is this activity table data flow here is reading from the first one. So let's have a look at how we're doing this. I've got my dimensions. Okay, my dim operation table is effectively connecting to a source, okay, and this source is my activity source query, which itself is connecting to that data flow that ran first. And then I'm using a reference to say, okay, take that data, remove the columns that I don't want, create a unique list of those items, and add effectively a surrogate key to my data. And hey presto, I've got a nice dim table. And then same thing for the other two ones. Unique list of workspace, unique list of capacity. It doesn't matter what that is, but for the purpose of this, it's producing data from a big bulk data set. Now, somewhat counterintuitively, I'd see a lot of people would disable that load and say, I don't want that data again. It's already been loaded up there. Why would I load it again? right? That's the kind of the obvious thinking. And if I enable this for load, you're going to see things change a little bit. So now we have these new icons, and now that says it's a linked identity. It's got a little chain link on it. And these ones here have the lightning, and that's called a computed entity. Some computed table, beg your pardon. They renamed it ages ago, but still. So what does that mean? A linked entity is saying the data has already been processed. I'm going to refer to it in this data flow. I'm going to enable it for load, but I'm not actually having to run it again. It's kind of like a pointer back to the original one. It creates a dependency, and then from here, I'm going to query and get a distinct list of operations, workspaces, and capacity. I'm going to close this, and I'm going to do the same to the third activity one. Fact activity. And it's the exact same thing. This one is referring to other data flows upstream. It's again referring to that same activity source, the first of the three, but it's also referring to my 3 DIMs because I do a join to grab the unique ID that I created in those DIM queries, okay? So now I have, again, 4 linked entities and a computed entity. What does that mean? What's actually happening? The linked entity is saying, okay, it's already created for me and prepped. I don't need to read it again. I'm not actually going to scan and read anything. It's there. My computed entities are going to say, yeah, it's there, and I'm going to do my transformations. But what's the difference? The linked entity, it actually uses the enhanced compute engine, which technically puts the data from the first data flow into a SQL cache. It's effectively said, don't do what data flows normally do and store it as a CSV in Data Lake, which is how they store the results. And if you've ever attached your workspace to your own Azure Data Lake, you can see the outcome of your data flows, CSV files. Every time they run, creates another one. And it is a CSV on Data Lake. But the enhanced compute engine says, hey, there's going to be things happening to this data downstream, doing transformations that are actually going to be quicker if you just threw it into SQL. So that's what it's doing. Instead of saying, put it on a CSV on Data Lake, it's going into a SQL database, SQL cache, let's say. It's a SQL database you don't have access to or can't see, but that's effectively what it's doing. And what that means is that these then computed entities are effectively like running a SQL query to do a group by or a join or whatever to your query, instead of reading from a CSV, using the Power Query engine to do your merge. It's like, hey, it's all in SQL. Write a SQL query under the bonnet, and I just give you the benefit of that. So I'm going to close this. And I'm going to run my first activity one. The sales one here, the sales one here, and the sales one here are out of the equation. I'm just going to run my staging activity JSON. But now that I've got linked entities, what's going to happen? It says there actually is a dependency. And I now know that if I refresh, hey, that one needs to. And then so does the third one. It generates a forced refresh downstream. Sometimes you don't want that because there might be dependencies in multiple places, and you can turn it off with a little bit of crafting. And that crafting is to move your downstream data flows to a separate workspace. So if my transform activity DIMs and my fact got moved to a separate workspace, that automatic refresh, like you just saw 3 of them run, would not happen. And then you're back to doing your own marshalling of the downstream. Okay? If they're in the same workspace, they're going. They're all going to run, and you can't control that. What's the impact? Why would you do that? I've created here another process where this sales source CSV is staging an 800 megabyte CSV, and then I'm doing 4 downstream things. Kind of the same, creating DIMs, I'm taking a fact table, but I'm grouping my fact table, and so forth. Doesn't matter too much what exactly I'm doing, but it's doing stuff to the data downstream. And what I did is I took the linked entities of all the subsequent ones, and I ran this process twice. Once I ran it by me running the first one, then the second, then the third, then the fourth. And then the second time, I turned the linked entities on and ran the first one, and they all ran. How much impact is that going to be? So here's my linked entity. It's turned off. Obviously, the last one I did was run them all. If I look at the history, you'll see here, the outcome of this history is just running that one table in this data flow. But if I have the linked entities turned on downstream, in this refresh, I'm going to see all of the downstream data flows as well in my history. Okay, so I'm going to close this and see if it was one of these. You can see now, here's my data flow name, CSV, my DIMs, my facts, and then there's a fourth one grouping them. And you'll see that it has all of those durations in it. Now, this is nice to look at, but I've taken this data and I've plotted the 4 individual ones on a Gantt chart and those on a Gantt chart so you can see the actual impact. And here is that Gantt chart. This here is the refresh time of the 4 data flows with Enhanced Compute Engine turned off. Okay, it ran one, then it ran the 3 tables in the second one, and then the third, and then the fourth, okay? Now, I turned all the linked entities on, and everything went to Enhanced Compute Engine. And just in terms of duration, I know it's small, my zoom it wasn't working, but that number there says 202 seconds. That's how long it took for all 4 to run. Okay? Now let's look at the output of the Enhanced Compute Engine turned on. Again, it's a little counterintuitive. I can see the first one 1, 2, 3 times. It's just showing because it kind of includes that duration for the bottom ones. But the 3 times it's run, it hasn't run linearly. It's just saying that was part of my overall process. That's just for you to see. So don't get confused and say it ran 3 times. It didn't. It ran once. But the subsequent processes said, hey, it's included as part of my refresh. But you can see everything is happening in complete parallel. And my overall duration here turned to 48 seconds. Okay? That's a small example of data. If you're doing this with combining multiple CSVs or multiple JSONs that are quite large, the impact is enormous. And we're doing that in some of our customers, and it's really proved to massively fast-track duration of data flows. Okay? The last little bit to show is the Fabric part. Okay? So really simple. Again, I'm not going to go into this too much. I have created a Fabric pipeline, which is doing the same thing. The bonus of this and the loss of this, the bonus is I don't need to go to Azure portal and create stuff in Azure. Everything is within Power BI. Okay? It's taking a bit of time to run, to refresh. I'll kick this off, and I'm also going to go to my last slide because we are at time. And we'll pop back and have a look at that Fabric thing a bit after the session if we need to. But that's the end of the session. I thank you so much for spending your time joining this session. Feedback and everything, if you've been to any session, speakers are hungry for that. The event is hungry for that. Please jump on and leave the feedback for the event and the session here. So thank you so much for your time.